Hello. Thank you. Hello, everyone. It's nice to be here in front of Hardware Meetup. We hosted Hardware Meetup before, but this is my first time speaking, so I'm pretty excited. My name is... thank you. My name is Hazal, and I'm a developer advocate here at Viam. Let's go through the slides. And I'm very passionate about creating sustainable solutions for the betterment of society. And I'm very lucky that my day-to-day involves me building smart devices that interacts with software and hardware integration. And today I'm going to tell you a story about battling a common problem we all face in our offices and homes everywhere. It is a story about the thermostat. I guess let's continue here. It is about tackling a common problem we all have. Is it too cold in the office? Is it too warm in the office? We don't really know. I'm sure you guys all, like everybody argued with their partner around like which temperature do you have to have in order to have a perfect night of sleep. So in our office, we had the same problem. As you can see from our Slack messages, people were constantly complaining about the temperature and they would never had an agreement around what temperature the office had to be around. And with further research, we realized that that's because our office had two specific independent heating and cooling systems, and one of them was heating our office to a different temperature, and the other one was cooling the office to a different one. And one day, our VP of engineering, Steve, decided to do something about it, and probably because he was just too worried that his team was constantly arguing over it. And he grabbed some ESP32s, it's that image above there, attached the TMP36 analog temperature sensors, and he started gathering data for temperature all around the office. And he used the Viam platform, which is an app that manages all of your smart machines from one place and ensures secure communication between your devices, mobile apps, and the cloud to configure his components. Here you can see the board, which is the ESP32, and all of his services securely in the app, and start getting some measurements through the platform. And here I want to talk a little bit about how he queried the sensor data. So you see here, there's a graph where it talks about the conversions between Celsius and Fahrenheit. I want to do a quick intermission and say that I'm from Turkey, and I use Celsius as my temperature measurement unit, and I don't seem to get Fahrenheit right for the life of me. So I added conversions over there for you to see, but basically what was happening in our office is that the building was heating our office to around like 31 degrees Celsius in some areas, and then our cooling system, like AC unit, was trying to cool it down to around 21%, like 21 degrees. And the vertical lines over here, like here you can see the temperatures, and then here you can see the different zones around the office where there are different measurements. And these two heating systems obviously was not great for the environment, because imagine like you're trying to heat up a space all the time, but then you're also trying to cool up that same space all the time. Not great. He used a Grafana integration to create this graph and actually analyze the data to see, okay, we have a problem here, how can we automate it? This is a photo of our current HVAC system. Just for context, our HVAC system has sliders on it, and you can change the temperature and turn it on and off in different zones and areas of the office. He realized that by automating the actuation of these switches, we can gain control over the system and actually interoperate it successfully within the system that we fully control. For that, he created, with our hardware engineer, Chris, I want to give him a shout out, I'm not sure if he's here. He created a custom hardware that you can attach on top of the HVAC panels, and this included a Raspberry Pi that's running a VM server, a 3D printed gantry for traversing the HVAC, limit switches to turn it on and off, a small DC motor, a simple controller, and a chassis that incorporates all the electronics on top of it. And here I want to talk a little bit about the code. Then they created a small code module that receives on and off commands and actuates the gantry system accordingly to adjust the slide switch. We published this AC switch module into the Viam registry, which is a place that has a lot of components and services for you to use. So if you want to use it, you can go to the registry and actually use that module that they created. But basically, the configuration maps HVAC units and temperature sensors to different zones. And by running a script hourly, it is getting data sensor, like temperature data, and controlling the HVAC units based on the comparison of the average data of that place and then desired level of heat and temperature in that area. I added a QR code here. If you want to see the full code, it goes to the repository. And now we have two HVAC systems that work perfectly together at a comfortable level of heat, and it is also saving energy. What does the future hold? So you can create a system where you get notifications about the smart device that you created and get real-time alerts using webhooks. You can do remote debugging and preventative maintenance, and you can create an app to view dashboards. The opportunities are endless when it comes to climate tech and edge technologies. And I want to ask a question here: what other efficiencies you might discover for sustainability if we were data-driven in more aspects of life? I also added some additional resources. The first one is the blog post if anyone wants to follow and do the project of their own. I also added a link to the VM docs, which includes a lot of resources as well as some other tutorials, and a link to our Discord, which is where our community is. And if you ever build this project, you can ask questions and get support there, as well as share any project that you're currently working on. Thank you. Over there. Any questions?
Does the system account for how many people are in the facility? Because that could affect the temperature.
So it basically has a limit of if it's 26 degrees and up, it's usually too warm for people. It just automatically activates the system and like moves the slide to a temperature that's a little bit more comfortable. So if there's more people in the same place, it will probably be faster for it to hit that limit.
Seems like there's a lot of opportunity for social games there. Like you could integrate a voting and a chat bot.
Uh-huh.
You know, in a Slack bot, something like that. People could vote on the temperatures.
That
You could
would
have
be
warfare, like
a
different sides
pure
of the
chaos.
office.
Literally a pure chaos. But that would be very fun. You can also like add AI and it could like detect someone's face and does something according to that. Maybe I'm always warm and I just want the office always cold, and like I could do stuff like that for sure.
Sleeping at your desk, just turn down the temperature.
Totally.
Apart from being a really great demo of being able to control a motion platform with VM's platform, why not just wire up a couple opto isolators to the switch and control it electrically? No motion components, no switch to wear out. They have a limit on how many times you can switch them, by the way. Just curious, was it specifically because you wanted it as a demo, or because you didn't want to raise the eyebrows of the people who actually own the building that you're renting from, or just because it was, like more fun to build it with a screwdriver and a gantry and stuff?
Yeah. I think it's both. Like one of them, we don't have control over the building heating structure, so we couldn't do anything about that. And then the second one is our system, like the HVAC system is closed. So first you have to open it and then slide it and do all this other interactions. And we wanted it to be a little bit dependent on the limits of how like cold and warm in the specific areas. I think the main issue in the office was the fact that in different areas, if it was different temperatures. And we always build very fun robots as what the company entails. So I think one reason was just like, oh wow, I have a problem. How can I fix this by building a smart machine?
Hi, I have a question. So you mentioned that there's like a code sample available and there's something on the registry. Could you talk more about what the registry is and how that's important for hardware?
Yes, for sure. Let me go to the place. Okay. So we, like, as a platform, we innately support a bunch of components and services. This could be a board like Raspberry Pi, or an ultrasonic sensor, or a webcam, which is a camera. And when it comes to services, it can be computer vision, it can be data management, it can be SLAM. And obviously, as hardware engineers, you will sometimes have stuff that we don't natively support. And you can go to the registry and you can either see another driver that an engineer or hobbyist created, and you can use that, or you can create your own modules and add it into the registry. You can think of it as like a marketplace for people to get drivers for their components and services. So this is one that Steve and Chris created and added into the registry. So if anybody has something similar, they can use that into their smart device and add it into their configuration and be able to control their device easily. And you asked another thing about.
Oh, just why is that important for hardware?
Okay.
I can
Yeah. Cool.
I know this isn't something you actually talked about, but I'm just wondering what the basic philosophy is behind your integration with ROS. Is the basic philosophy that you have kind of an isolated ROS system, and then you just sort of like hooks into it and put it on the cloud, or is there something? Or I guess that's just kind of my guess, but could you maybe explain that a little bit?
So in this project, we didn't use ROS at all.
Oh, okay. You're just only want to have questions about the project and not about.
Oh,
VM
so
in
you're
general?
asking about like ROS and VM interaction in general?
Oh, yeah.
Okay, so we have a bunch of ROS interactions, and if you go to our blog post, there are a bunch of tutorials around how to integrate ROS within VM products and vice versa. So like how to integrate some of the VM data management or cloud storage into the existing ROS project that you have. But our main philosophy is it is not a competitor, it is just an additional software platform that you can use to do certain things with your devices.
So those devices, like to connect them to that app that VM was running, like did you have to make your own like virtual network that is connected to VM, or like is there an API key? Like how does that happen?
Yeah, so the first step is obviously creating a VM account. Takes a minute. And then you download your VM server into the machine that you want to use. In this case, we used an ESP32, which is a micro RDK, and then he used a Raspberry Pi, which is the actual RDK. And you can download your server into that machine. It could be your laptop, it could be a microcontroller, it could be a single board computer, and then it automatically connects. Obviously, each specific robot has its own API key and secrets, so it's very secure, and you can only connect to that one specific robot, and other people can't connect to your device from somewhere else. But then you can immediately start adding your components and services, and you don't have to write any additional code to control or test them. So if you had a webcam, you can just automatically connect your webcam to your Raspberry Pi and then add your camera over here to your device and then save your configuration. And then if you go to the testing panel, then you will be able to see your camera and vision.
Gotcha. So there was like one server, and then all around the office, the devices talk to that server.
Yeah, so basically Steve had just one organization that had like 10 different devices on it, and then he just named them with the zones, and like one of them is here, one of them is over there, one of them is in the kitchen, and then he would just get measurements from all of them at the same time.
Nice, super cool. Thanks.
Time for a couple more questions.
I think there's a question in the back, I'm not sure.
sorry if it might be nitpicking, but how did you decide on the placement of the sensors?
How did we decide of the placement of the sensors?
Yeah, assuming your office is like a big open area, how did you decide on where to keep the temperature sensors?
100% people complaining. So we have one specific place, and the location is like M2 in the back, and it's so hot. And I think you can see over here, like down there, M2, the red one, it goes like up to here. Whenever we have a meeting over there, everyone's sweating, and then the kitchen is always cold. So like most of the times there were specific areas that people needed data, because we were like, how is this possible? Like, I'm wearing shorts in one place and then I need a blanket in another place.
Last question.
Maybe that was the last question.
Okay. Oh.
I did something similar in my apartment years ago, and I was mostly focusing on if it would make my life more productive.
Mhm.
I wonder if making your temperature more optimal, if you see more productive workers.
I mean, maybe because it was really a big problem. Like, I'm not kidding you. We added Viam blankets to our onboarding swag bag because people were constantly complaining on Slack. And like, we have deodorants in our restrooms and it's always fully stacked because if it's warm, like, it's not a great place to work in. So I think after like controlling our temperature, obviously, like, I can actually check the temperature outside and be like, okay, today is a warm day, I can actually dress up warm and I'm not gonna have any surprises in the office. So like, I'm pretty sure it impacted productivity in some way. Cool. Thank you.